day, everyone! Today we'll be teaching you about dimensional analysis, part of LQ1 for chemical engineering calculations. Now, dimensional analysis is somewhat of a solving method that involves the relationships between the units and dimensions of certain quantities. Typically, you'd encounter questions here that involve unit conversion and, for this course, identifying the units of a given constant or term. So let's head over to our problem solving portion. Here's our problem from Basic Principles and Calculations in Chemical Engineering by Himmelblau and Driggs, 8th edition. So you may pause the video to have more time to read it. Upon looking at the problem, we can see some important parts that we need to consider to solve it. There's a given equation, a list of units, and we were also being asked for the units of the constant 0.943 as shown in the equation. We'll be making use of the concepts we tackled in dimensional analysis to derive its units. So let's start by breaking down each component of this equation into their respective units, which we'll do by substituting the corresponding unit from our given values earlier to the equation. For our constant, we'll simply use the letter x to represent all of its units. Don't worry about it looking too complex, just make sure you write the units correctly. For units that were substituted to values with exponents, which are k and rho, we'll also be applying the exponents to each of the units as shown. So after breaking it down into this form, we now have to determine the units of this entire quantity multiplied to our unknown value. To do that, we'd have to take into consideration each of the dimensions, so r, feet, and so on, and it would be easier for us to do this by doing it individually for each of the dimensions. So now I'm going to introduce a technique for simplifying exponents in complex terms such as this one. Notice how we have some sort of a main fraction which contains fractions in both its numerator and denominator. And I've rewritten the denominator so that you can see the division more clearly. Basically, what we're going to do is always add the exponents when they're placed here on the outer area and subtract when they're here on the inner area. So let's start with BTU, which we can see is present in various quantities in our equation. Since both of the BTU dimensions are on the outer area of the fraction, simply add their exponents and don't forget to multiply the 1/4 exponent that applies to the entire complex term. So we should only be getting BTU raised to 1 from this. So the same thing applies to our next unit r, which can be found in both the inner and outer areas. Since r cubed and r squared is in the inner area, we'll be treating them as negative when we solve for the exponents. Here, we should be getting r raised to -1. We'll be repeating this process for all of the dimensions, so feel free to pause before I reveal all of the values. So now that we have all of the proper units of that complex term, we can now combine all of them by simply multiplying them with each other. So we then compare it to the units of h on the left hand side, which was given earlier, and you can also see it on the right hand side of our slide. However, if we look at the units on both sides, they seem to be the same, right? Because of that, we can say that our x would just be equal to 1. And from there, we can actually conclude that our constant 0.943 has no units associated with it. It's dimensionless. And that actually concludes our practice problem for dimensional analysis. Thank you, and we wish you good luck in your exams.